Good afternoon, everyone. Hi, I'm Dominic Cooney, Dominic C. This is service workers, and there's another talk about touch events. So this is an awfully big room for a pretty small talk, but we'll see how we go. So I wanted to start where I grew up, actually. 100-year-old house in Australia, and it's surrounded by bush. And you know, it's the sort of place, if you want to go and pop in on the neighbors, you're putting on boots and you're watching out for snakes. And one day my dad brought home this modem and a piece of paper with the username and password on it. And so, you know, plug this in and red lights are blinking and trumpet windsock is like spewing all this stuff. And then there's the login prompt. So I really visually remember, like, the username and password weren't echoed. It was a real act of faith to be inputting these things. And, you know, that was all interesting, like novelty. But I just got chills when I realized, like 5 minutes after that, I'm browsing this directory listing that's on a computer in like the other hemisphere in some North American university. That was just like total wow. And that was the first time I used the internet. And of course it was Gopher, so it like, it wasn't even interesting. It was like just clicking through endless directories. It wasn't even the web. And so now, you know, I've moved. I live in one of the biggest cities on earth, in Tokyo. I work at Google in Tokyo on Service Worker. And last week I was on this train, commuter train, going into work with about 150 of my closest friends. And I'm not talking about 150 of my closest friends on the train. That was like in my carriage. You get on these things and you're like this, you can't move. So when you're getting on, it's a real maneuver. You got to get that phone up in front of your face, or you're not doing anything the whole way into work. So usually, you know, I'm going into work, I read a book on Kindle or something like that. And so this, you know, this day last week, you know, I was bored of that. And so I flipped into the browser, and there's this web app we've been using for testing Service Worker. It's called Train to Thrill. And it really kind of represents to me like the best of the internet. It pulls train images from Flickr, which doesn't sound that interesting. In Japan, we have these people called Densho Otaku, which are like train nerds who are really into this stuff and like train pics and stuff. But for some reason, these Flickr images have these awesome comments about like, this is the station and like when it was built and all this sort of stuff. And so, you know, I was browsing that. That's lots of fun. And, you know, so I had my fill of trains. And so then, you know, I flipped to Hacker News. I will confess that I read Hacker News. And I got a network error. I was offline. And it was just like, what's going on? Because I do have network coverage all the way to work. Although when you're packed into this metal object going at 60 kilometers an hour with 150 of your closest friends who are also online, it's not super fast. And then I realized yesterday I'd been messing around with this test app on my phone, and I'd put my phone into airplane mode. I was offline. And so, you know, I flipped it off and then I reloaded and I could read Hacker News. But it just, I got the same chills. This time, not because I was online, but because I was offline. And you know, compared to the Kindle app, which you have to download and install, and it takes a while to start up, and et cetera, this was like just using the web, zero friction. And the reason that worked is because that demo uses Service Worker, which lets you implement offline web applications. So I wanted to talk today about 3 things, basically. First, I wanted to show you like actual code using the Service Worker APIs, what a web dev would write. Because I think a lot of you have probably heard of Service Worker, but I also understand a lot of people might not be exactly clear on like what it is or how it works. And so a way to like cut through all of that is to like, let's just look at the code. And then secondly, I think Service Worker could be a useful bit of infrastructure for building new features on top of. And so I thought, again, let's just look at the code. Let's look at push messaging in Blink and see how it's built on top of Service Worker. And you'll get some idea of how you could build a feature on top of Service Worker. And then lastly, I thought I'd talk briefly about how the service worker team is operating. We're like a dozen people spread around the world. Like, how do you implement a web standard in that environment? Okay, so there's no link to my slides because I have no slides. This is the web app I was telling you about when you look at it on the desktop. I can't show you this working offline because my projection relies on me being online. And also this is dev. But if you have Chrome Canary on your Windows laptop or your Mac laptop, or you're building Chrome on Linux, you can go to that URL or just search for like Jake Archibald Train to Thrill, and you can play around with this. Like, you load it and then you go offline and you reload it, and it should work offline. And it does that using a service worker, which you can see right here. Is this, is this readable? Better? One more. Okay. So there's a whole lot of code here. But the interesting line is this navigator.serviceworker.register. That's how you kick off a service worker. And it's not unlike starting a worker. You name a JavaScript file. This also has this parameter called scope that says /train to thrill /. So what this does is it kicks off the browser downloading that JavaScript and executing it. And I guess I'll talk a little bit about what scopes mean later. So here's the service worker JavaScript file is like all crunched together by some install step with the way this app is deployed. But here's like what the service worker script is, basically. And so we evaluate this basically in a worker-like context. And the environment has a few events, one of which is this on install. Oh, that's good. One of which is this on install. And so the first time we are running your service worker script, we will fire that event. And in Train to Thrill's case, it uses this new API called caches that's also spec'd with service worker to say, I know in future I'm going to need these bunch of resources, and it tells the browser to go and fetch them. So you might say, like, this is a little bit like app cache, except it's not declarative and whatever, like, yeah. So you name some URLs. Okay, so how offline works at that point is the next time you load this page, if the page falls under that scope parameter, you become what we call controlled by the service worker. What that means is every subsequent network request that page makes, that's whether it's to your origin or any random origin, whatever, for anything, we are going to route that event, we're going to route that request through the service worker, and we fire this event called the fetch event. So there's another event in the install step called activate, which is like to do with upgrading service workers, but skip that for now. We fire this event called the fetch event, and you can respond to this any way you like. And so what this app, Train to Thrill, does is it actually races a request to Flickr for images and JSON about like Flickr search results for trains, with a lookup in the cache for those same kinds of requests. And in doing this, it implements this pattern that it calls offline first. And this is basically what a native app does on Android or iPhone, right? Except the difference is, your sort of offline stuff is all implemented in Java and XML and whatever. And then, you make these network requests and populate fresh data. And it's the same pattern here. You can now make this work on the web with service worker. So now we're starting to get a little bit away from app cache, frankly, because this is like different and more flexible, and it's just writing JavaScript. And we've had great collaboration with the DevTools team, and if you have some problem with your service worker, you just set breakpoints on this stuff and debug it. So that's what service worker basically does for offline. we got heaps of time. So is there any questions at this point? Or, yeah, feel free to interrupt me. How about we'll say that? Yeah. Yeah, there's a question, is there any restriction on the kind of data you can handle in requests and responses? And you mentioned post data. So did we implement post data yet? The answer is no, but our implementation is a subset, so there might be some practical limitations of what you can do today. I think we do have post bodies, but I could be wrong about that. Yeah, we have post, but not like multi-part form data, something like that. That sounds right. Thanks, Daniel. Yeah, we don't handle WebSockets. WebRTC, yeah. So there's a few things we don't handle yet. And another thing that's kind of, this sounds a little bit scary from a security perspective, right? Because you can intercept the request for like Google Analytics script and do any random stuff. And the idea there at a high level is basically like you're controlling the page anyway, so you could have probably fooled yourself in the page compared to fooling yourself in the service worker. So we're not too worried about that. What if you want to do cross-origin stuff? Like you never meant to see those bytes. How do you pass them back? If you look at the way these APIs work, they're all based on promises. So you can fetch something and get a response back that's opaque and pass that promise back into the page in the service worker after making some decisions about the parts that you can see, maybe the request headers. And you can implement very flexible patterns that way. Sure. Yeah, so train to thrill like does its own messing with headers and things so it can tell where requests are going. And it's quite sophisticated. Like when you load train to thrill and you're offline, there's no way to really tell if you're actually offline, right? Because you might be offline in an elevator offline or offline in a speeding train offline. So it'll always send those requests out, and then in the event of errors, it'll actually respond into the page and pop up this little bubble UI saying like, the connectivity has been derailed, which is really cute. Yeah, so basically you can implement like app cache style offline with this thing. But if you push it just like 1 degree further, it's just like amazingly more responsive and cool offline. I know this is like a lot of code to look on one slide, but it's very honest because this is like a real working thing, right? And you can just hit this and start debugging it and play with it. Although I think like the script in the page might be minified or something, which is a little unfriendly, but I think the service worker is not, perhaps, so that's cool. All right, so let's move on and look at some internals. I mentioned building a feature on top of service worker. Well, what does that even mean? Why would you want to do that? Service worker isn't just about offline. This is just the first thing that service worker lets you do. The fundamental capability a service worker gives us is we can run a little bit of script while a tab is not open for that site. And the browser controls the lifetime of this background thread. It's really for really short-lived events. This isn't a long-running thing like a worker. After train to thrill loads, 10 seconds of inactivity goes by and we shut that thread down and kill it. And we can just start it up and shut it down at will if the page makes XHR or whatever, whenever we want. This is great for battery, it's great for performance. So if you have any kind of feature that would benefit from doing something when the page is closed, then service worker is a great vehicle to do that. So some examples of features like that are push messaging. If you want to push a message from the cloud to the device, the user might have closed your tab, Chrome might have evicted your tab, Android might have like tossed out Chrome, like you're long gone. But with the service worker, there's an entity there that you can bootstrap and deliver this event into that's relatively lightweight compared to like a full browser page, open tab, that sort of thing. Another example is notifications. You know, on Android, when an app has a notification up, the app might not actually be running behind that, right? It's just when you tap on it that it's vivified and brought back to life and runs. And so now web pages could do the same thing with notifications integrated with service worker. Another one is geofences. You don't want to have that page open all the time to implement a geofence. The whole point is that the operating system's just in a very efficient way watching the geolocation and giving you some alert when you've crossed into the geofenced region. So not to pick on any particular code, but again, it's very honest just to look at what's in the code base, right? So I thought we would just look at how push messaging is implemented. And there's basically two things you need to work out. One is how the web page asks to get your stuff, like registering. And the other one is then, okay, how do you spin up a service worker to deliver one of these events? So for the registering part, that's going to be some developer API. So we start in Blink. I'm going to need to zoom in again a little bit. I'm not sure how this is going to go. So, this is implemented as a module. Can I get rid of this guy? Yeah. This is implemented as a module, and it adds, going to have to zoom every time. What can I do? Resolution? Control plus? Oh, this header isn't crazy big.
Well, what is it?
You can read it, but there's this huge UI that we can't slim down. Anyway, this is probably all right. We'll have this little thin window into the code. Yeah, is this readable? Roughly? All right, so this is a partial interface. If you've done API work in Blink, this is probably familiar. And this is basically saying, I want to supplement Navigator, so like navigator.blah, with my blah. And in this case, it's a thing called push, and it has one of these push manager things. And so we can look in the push manager, which will have its own IDL. I was clicking through this all last night, pretty much for the first time. And it has a couple of methods, and one of them's register, right? So the API these guys have designed for registering for push messages is you're going to say navigator.push.register. And it looks like it has no parameters or something, which is kind of interesting. And so then really this is a great example. You can just start drilling back and back. So here's this thing, register push message. Now remember, this is in the page, so it's running in the document. It's a good thing to make your hookup work there, because if you need to display UI or anything to the user, that's a context where they have Chrome open and some UI up. So that might be appropriate for your feature. And so the important part here is there's this thing, Navigator Service Worker, right here, that is a supplement to the Navigator. So this is how you pull off these supplemental things. You get a Navigator Service Worker, and you get its provider, and you have one of these web types. Okay? So the web types are in the, they're now in, they're in the web API of Blink, and so they're used in Chrome or usable in Chrome, right? So now we can go into the renderer and see the code that this thing was calling. Oh, this is not going to work, is it? Oh, there's a feature I can use. This is why we need PMs. One of the many reasons. This is Kenji, Service Worker PM from Tokyo, everybody. I need to what? Oh, can I type? What do I type?
To go to Chrome://settings.
What?
Chrome://settings.
Okay.
You're learning other things then. This is all
He's using a fancy keyboard. I don't know. Accessibility.
There's also an extension that
Okay.
Enable screen modifier.
Oh, this could be good.
And you can use Control Alt this and this.
Oh, neat. Okay.
Okay.
Sure.
Can try.
Sure. Let's go back here.
Just put the resolution back to some kind of normal thing. Maybe.
Oh, so I should unzoom?
Yeah, I think.
And then Control
Alt brightness
Right.
up and down.
Okay.
Is that better?
Nope. Nope.
Doesn't show up on the screen?
Nope.
Yeah.
Okay, well.
You know what? I think I might skip to the third part of my talk. So here's an exercise for you, the listener. There's this push messaging code, and there's this great code search.chromium.org. Basically, you can look at this as an example and drill forward and back. What this boils down to in practice is you're going to have to implement something that jumps from Blink into Chrome and from the Chrome render into the Chrome browser. The service worker like a database of registrations, lives in the Chrome browser. Once you're in the browser, passing one of those web service worker providers across that boundary, these things have this integer ID, which is an ephemeral ID. So per session, those things are going to change. So you can't rely on them. You're going to be able to look up a registration. So when you call navigator.serviceworker.register, the object you're cooking up in the browser is actually one of these service worker registrations. These things have a durable identifier called a registration ID. They're unique per storage partition. And then you can store that along with your feature. And then it's like, how many lines of code? It's one async callback given a registration ID to get the service worker registration for that guy in the Chrome browser. And then it's like one line of code to dispatch an event to this guy. And that's pretty much how you do it. Everything else is handled for you by us. We'll like find a renderer, we'll start that thread, and then you'll call your dispatch event method or whatever. We'll run your event and we'll decide when to shut you down. So there's kind of a checklist of things that like, does your feature make sense to implement on top of service worker or not? You want to run when the tab is closed, but you can run in an event very quickly. You don't have to have any long running stuff. Off the top of my head, those are the two things which like if you contravene, it's just not going to work. Anything else, probably can be made to make sense. Any questions at this point? Yeah. So workers have a method called terminate, and we took it away. So the service worker used to be able to at least shut itself down. Now it can't even do that. It's all in the browser's hands. Let's say you're responding to a fetch, one of these fetch events, and you need to go and fetch like 10 things from the network to do that. You can tell the fetch event, I want you to, you basically reply to the fetch event with a promise. And then it's until that promise is resolved that we will kind of let you run. But there can and will be limits in the future. So yeah, it doesn't explicitly control its lifetime. It can just ask for more time, which it'll maybe get, and we'll probably have better and better heuristics to decide if you've gone off the rails and kill and restart you. Yeah. So it's a challenge for web devs really, because like if you touch the global state of your service worker and you're doing some like in-memory cache or something, that's fine. If you touch the global state of your service worker and you're collecting some 3 things that you plan to handle the next fetch event with, that's not fine, because between the 3rd and 4th event, we might kill and restart you just because there's reasons, system-wide reasons to do that. Does that answer your question? Okay, I got about 7 minutes left. So I thought, let me see, let me unzoom this. And I do actually have some slides, so I lied about having no slides. I wanted you to understand how we, the service worker team, are working, because if you work with us, it'll help you to know what makes us tick. And it might also be helpful if you're implementing web platform features in Blink to see what we're doing. Maybe some of the things we do make sense for you. Before I worked on service worker, I worked on web components with Dimitri, so I was either like on the field or ringside seats for like shipping 4 things now. So I've seen this a little bit. And this is all my opinion and totally unvetted by anyone. So I think one thing that you really need that on many teams is actually implicit is you need to have a goal. Like, what are you trying to do? And everyone on your team should know it. The reason this is important is hopefully your team's like some number of people, and probably in practical sense, they're spread all around the world. So you want people to be able to make good decisions autonomously. And I think the best way to enable them to do that is to just let them know, like, what are we trying to do? So the goal needs to be like small enough that you can make a practical decision based on this goal. It also needs to be big enough that like achieving it is not trivial, it's really something meaningful. And people, given a goal, like they want to succeed. So you want to pick a goal where like success is good and isn't going to motivate anything that you don't want to have happen. So our goal on the service worker team, we aren't sophisticated enough for 3 dimensions. We have 1 dimension. It's to increase the number of service worker controlled page loads, because to us, that means our feature is being used by developers in the wild, which means we've solved numerous problems, including implementing it and shipping it, and developers understand it and developers can use it and find it useful, etc. So first, I think you need to have a goal. Secondly, you really need to have a team. It isn't a happy place to be implementing a web platform feature in Blink by yourself. You want to have at least one other person like really rooting for you and invested in your success. So on our team, we roughly have these roles. We have people who are primarily responsible for producing the specification, for understanding where the other vendors are at, managing the relationship with them, getting the developer ergonomics of the API right, etc. These are like spec world people. Then we have implementers. These guys are hacking C++ and Chrome and Blink. Their responsibility is to like, you know, make it go, make it secure, reasonably fast, like you name it. And these things really mean like this is your job, just concentrate on this. Like the implementers don't run into the specification committee and say like, oh, this method should have a slightly different name, let's paint the bike shed. And likewise, the spec implementers, the spec people don't run into the implementation and say like, you're not using enough threading here. So these roles are really like, it's really helpful to separate these in just so many ways. Like one example is there's a lot of negotiation with other browser vendors, right? And we have our like agenda as implementers and things that make it easy. It's really good to have someone, even if they're like on your team and on your side, to at least have some possibility of impartiality where they can weigh concerns of developer ergonomics and your implementer concerns and Mozilla's implementer concerns, etc. So it's really good to have those roles be different. Okay, then you need like a lead to just make a conducive environment for getting things done for everyone on the team. And it's really good if you can have someone play the role of product manager who really understands like who is the customer and what do they want. So our goal is to get this thing used, and to do that, you know, we need like developers to adopt it. And so we have a single use case that we're trying to enable, which is basically that, at least initially, which is that train to thrill offline use case. That's all we're focused on. It's really liberating because the implementers can just concentrate on that. It guides a whole lot of decisions and it's directly connected to the goal. So then you need some kind of process to just make this whole thing go. And I guess specifically I'm talking about the phase of life that the service worker team has just been through, which is like from nothing to shipping maybe. So the PM and the team understands like what the use cases are and they specify what those are. And it's really important that the whole team like lives and breathes this and understands what this means. Then the spec editor does their job and creates the spec. The implementer sits there and looks at the use case and says, okay, what bit of the spec do I need to pick up and implement to enable the use case? Once you have that as like a guiding decision function of what to do, energy is like intensely focused on a small part of the spec, and it's the part where all the value is for the users. So that's great. Then when our implementers implement something, of course they lay down code. They write tests, and then they also file spec issues, and this needs a little bit of explanation. So let's talk about the tests first. In Blink, traditionally we've written layout tests. They're great. You can access window internals, all kinds of fancy hooks. I think I'm out of time. Oh, 15 minutes? Oh, sweet. Okay. So there's all kinds of fancy testing hooks in Blink, which are great. We've said, you know what? No, we're not going to use those. We are going to write W3C style tests. So you can take the service worker tests today and run them in Firefox. You could even run them in Internet Explorer or whatever, even though that wouldn't make a whole lot of sense. The reasons we're doing this are like many, but the primary reason is we really, really, really care about compatibility. And when you're implementing a new web platform feature and implementations are coming up, like naturally some are faster and some are slower, naturally your compatibility risk is super high. naturally the spec is changing and might have some points that are vague and etc. If you are writing these executable tests, you're like condensing the DNA of the specification that is necessary for those important use cases into some executable form, which is super valuable. It's nice that it's accessible to other people, but it's also great for your own team. And so, of course, we do have some tests that need the Blink internals, like GC hooks and crashing tests and whatever. And so we've sequestered those off in like a subdirectory that we call Chromium. So the implementer is producing these tests. Now, what happens if the implementer reaches a point in the spec and it's like not quite clear what to do, or the spec like has some issue? They should stop what they're doing and pick up a new feature to implement, right? Of course not. This is just a recipe for going incredibly slowly. Our implementation never blocks on the spec, and our spec never blocks on the implementation. Instead, what our implementers do if they're faced with some uncertainty is they file a spec issue, which is what the spec people, the spec editors need to have some grist for their work queue, right? And they just say, this is unclear, not sure what to do. Hi, I'm Blink. We're going to just do this, and it might be right or wrong. And then we keep going. So then the spec editor comes back and can just work through this issues list and doesn't have to look at a whole lot of context and understand like a whole lot about what's going on in the implementation side of the project, because they've got this list of spec issues, right? And they'll fix them and incorporate them in the spec. They'll do the negotiations with other vendors, etc. And so, okay, where does that leave us? The spec issue could be resolved in a way that goes against the implementation and invalidates it. But that's fine, because the implementers now just have to look at the list of spec issues. They don't necessarily have to follow like the whole extent of what edits are happening in the spec. Because remember, we're focused on a use case, so we're only implementing a small part of the spec anyway. We just concentrate on those parts, and not only that, we can just look at the resolutions of the issues. So this is like super efficient. So where does that leave us? There's problems with this system. These are problems that everyone has, but maybe they're not so conscious of them, right? So one problem is that the spec changes without going through an issue that the implementers were watching. What do you do in that case? Today, our PM is like heroically reviewing the spec with reference to the implementation and finding where they've diverged. However, he's not a C++ hacker, and he doesn't have to understand like multiple processes and all this crap, because he can use the W3C test suite that we've written, right, to keep these things in line. That's a much more like high density artifact about what our code is actually doing. And we know that the code and the tests haven't diverged because we're running the tests automatically. One thing our team is going to do next is we're going to start automating the links between the tests and the spec. And I could show you some tools we're making to do that if you're interested. And what's left? I think that pretty much covers it. If the code gets out of whack with anything, the tests pick it up. If the tests get out of whack with anything, the test and spec reconciliation process we have picks it up, and that's going to be automated soon, I think. And then lastly, if spec issue resolution, which is like the high likelihood, high risk of invalidating the implementation happens, then it's easy. You're just looking at a subset of these issues. So this is our process. And I think this is a bit more defined than what most teams do, but I could be wrong, and I'm interested to hear like any feedback on this. Yeah. So shipping, it's really important. And this is my last slide. Everyone wants to ship. It's good to keep in mind that shipping isn't really the goal. I think at some point Service Worker might have lost sight of that, and we tried to ship something that was like not actually useful. And we pulled back at the last minute and worked out, oh, this doesn't make sense, because we'd lost sight of those use cases, I think. So what does it really take to ship? We understand it this way. Not written in that document about the Blink launch process, but elsewhere on the Chromium wiki, there are these principles of the Chromium project: speed, stability, simplicity, and security. These are like hygiene factors that must be present for you to ship. secondly, there's this idea of moving the web forward. If you're implementing a new feature and you understand the use case that you're implementing, this is an easy case to make and understand. It's like, this is the use case that we enable. This is very uncomplicated. It's very simple. The third thing is compatibility, which I think is a bit murky in a lot of people's minds. The gold standard of compatibility is multiple interoperable implementations, right? That's what we all want. If you're implementing a new feature, the gold standard is unattainable. What do you shoot for? If you closely read the Blink, like what we believe launch process guidelines, etc., it says it right there. It says you want to have the possibility of compatibility for other vendors in the future. And so the way, you know, Service Worker team is supporting that is all this investment in the W3C tests, etc. To be honest, if you're implementing something new, it's the use cases and moving the web forward that is your strong suit and your best point. Compatibility risk is always higher for new features. And so I think at some point, the best thing to do is just quantify that by looking at how much the spec is changing relative to your implementation and tests, etc., and make it possible for it to be visible through the tests. And then the leads can make at least an informed decision, or I'd love to have feedback from the leads about whether, like, how we did on that. And then there's the whole like process, all the ceremony, bring out the marching band, like make this launch bug and have some intent to ship threads and all that sort of stuff. That stuff, you know, it's shouldn't be mysterious, and just find someone who's done it before, I think, and they can guide you through it. Yeah, so like, what does this mean in practice for us? Like, this wasn't this model of what it takes to ship wasn't abstract. Our triage process going up to the intent to ship, where if it compromises particularly stability, like security, and to a lesser extent speed, simplicity was a little bit easier for us because we didn't have any new UI. Like, to me, simplicity seems to often be about you not adding any new UI to the product. But if you have anything that might compromise those are your P1s. If there's anything that compromises your use case, those are your P2s. And compatibility, which is always not going to be your strongest suit, as long as you're measuring that, if there's anything you're aware of that compromises compatibility, then those are your P3s. And this, I felt, was very effective at helping us work through bugs up to launch. So that's it, I'm done. And we have like 7 minutes left. Any questions, comments? Oh, the whole, like, a good chunk of the Service Worker team is here. All of the San Francisco Mountain View people are here. So there's lots of people to answer questions. I'd love to give you demos in person later, by the way, too.
What's next?
Yeah, so, yeah, good question. What's next? Our goal is to increase the number of Service Worker controlled page loads. So we want to get people using this in the wild. So there's a lot of stuff coming from DevRel explaining how to implement service workers, these new patterns of offline first and that sort of thing. And frankly, like, we're really thrilled about Train to Thrill. Like, it works, it's great. It's like, it's way, way, way better. So we're pretty comfortable that we've got that use case for like a simple site well in hand. A bigger site, I think, is going to need higher performance. So that's going to be one thing we're going to work on. If you're getting bytes out of the cache and into the renderer, like, we serialize those operations too often. We copy those bytes like too many times. So that might be one area to work on. Another one is like developer ergonomics. Tools are great. We've had lots of support from the DevTools team, but they're still not there. So one specific example is, I mentioned the service worker lifetime is controlled by the browser. You might be in the middle of a debugging session with a great set of breakpoints and a call stack and variables in the console. Bang, like, you're dead. And so you have to start again. So it's things like that that we'll be working on. Right, so the question was, what's the impact on service workers on the amount of storage space on phones devoted to caches, because you're going to be like having a whole copy of the web around on your phone? Yeah, it could be a problem. So if we're wildly successful and lots of controlled service worker page loads are happening, we may change the goal. And I think in time, even these things will flip and compatibility will be primary to the moving the web forward thing, because we will have gotten most of the value. And so, yeah, that's definitely something that's on our radar that we're concerned about. The API is very cleverly designed. Like if the feature were to be turned off, pages won't break, just the offline stuff won't work. I mean, you can work hard to make a page that will break, but so we could start evicting caches if they're not used recently. There's all sorts of things we could do. Yeah, so example there, could the page indicate like this resource is disposable and I don't mind if you throw that away? Yeah, we could do something like that. In general, you know, there's lots of ways to store state on the client, IndexedDB, cookies and whatever. It'd be lovely if there was like some sensible overarching scheme that kind of didn't treat these as all separate things. Like we are hooked into, or hooking into like storage and quota and stuff. But yeah, that's a general problem, I think.
Performance in passing, and that you know that you're copying too much. I'm wondering how you're measuring speed overall. There's a lot of discussion in a lot of places about should we be measuring full apps or micro things or things that are like full apps, and there probably aren't with one service worker app at least. I'm curious what you think the team is doing.
So the question is, what are we doing to measure performance? There's like kind of controversy about, do you measure full apps or do you do micro benchmarking and that sort of thing. So speed is one of the core principles. So improving it is a great tailwind to your effort. However, even though there's lots of potential for more speed in service workers, we didn't delay shipping it. Because from our point of view in the offline use case, your infinities go from latency, which is a really high numerator, to your latency goes from infinity, which is a really high numerator, to non-infinity. And so that's a really big number. And so we improved speed by a really big number, arguably. What we were more worried about was not regressing existing stuff, because we have to have our hooks into the network stack. Fortunately, Chrome already has a lot of infrastructure for hooking the network. So we kind of got a free pass on that, which is good. So to be honest, security, stability, privacy, those were kind of more important to us than speed. Initially, we were really concerned about speed. A single thread in the background that we're going to serialize all network requests through, it sounds dicey. And we're going to run JavaScript, which is like getting faster every day, but it's not known to be a speed demon. So before we could even return any response content, we wrote a telemetry test that said, how long does it take to spin up a service worker and get a 200 response back from it with no content? At that time, that was all service workers could do. You couldn't even say okay. We'd hard-coded 200. We'd hard-coded the okay part of 200. I think if you sent 404s, you got like 404 okay or something like that. And so we found that, you know, on phones, it's in the single-digit number of milliseconds to do that round trip. And the scalability is linear, as you would expect in this system that is putting everything onto a single thread. And spinning up the service worker script was like 20 milliseconds, 30 milliseconds, although that script is trivial, admittedly. And we looked at that and we said, pages today are taking a second to load. So we think for now, you know, we can wing it. And so we just kept watching it over time in the micro benchmark sense. And if you just viscerally experience it with train to thrill, like it's bananas. It's so fast, this offline first thing. And so, yeah, we're very concerned about performance from the point of view of more demanding customers. But for now, yeah, that's all we've done. Not a whole lot, but not zero. Okay, Eric. Right, so Yeah, the question was, the spec reserves the right to kill a service worker at any time, and what's the actual implemented policy that we have today? I guess implicit in this question is, isn't there a risk that developers will come to expect one set of behavior from Chrome? It is a risk. Our policy today is, after like you're quiet on the network for I think 10 seconds, right, Michael? 10 seconds, you implemented it. Yeah, it's 10 seconds, I think. We will kill you, all right? And other times we'll kill you. When will we kill you other times? Do you guys have anything off the top of your head? Oh yeah, like if the service worker is unregistered, that sort of thing, if the tab goes away. So I guess we're out of time. I think the high order bit is, we talked about having a chaos mode where we kill you more randomly. And I think we'll look at that soon, because adoption, it probably won't be as fast as we like. So we do have a window of time where we can get ahead of that problem. Yeah, I'd love to take more questions because I think I saw one or two other hands, but we're out of time, so I might take them offline. Thanks a lot.